Hello guys, welcome back again. It's good to see you. In this video, I teach you a new title of physics. That title is 10 lenses equations. What is 10 lens equation is the relationship between object distance, image distance, and focal length. This relationship called 10 lenses equation, 1 over dO plus 1 over di is equal to 1 over f. This is general equation for 10 lenses. 1 over dO, what is dO? Distance between object and object length. Di, distance between image length, and f is focal length. You know that we have two kinds of 10 lenses. Converging lens. What is the equation for converging lens? If you see the figure, this is converging lens, and object is placed in front of the converging lens, and the image is formed. Okay, the image formed between center and focal points. The image form is real, is smaller than the object. If you represent the distance between object and lens by dO, and the distance between image and object, image and lens is di. Okay, what is the formula for converging lens? 1 over dO plus 1 over di is equal to 1 over f. This is the formula for converging lens. You can see the figure. Di is this distance. dO is the object, distance between object and lens, and f is the focal length. And now, what is the equation for diverging lens? It is diverging lens. I draw the diverging lens, and you know that I told you before, in diverging lens, the image in diverging lens is virtual, erect, and is smaller than object. You see in figure, the image is formed in this object. The image's form is virtual, erect, and is smaller than the object. Okay, this is the equation. 1 over dO minus 1 over di is equal minus 1 over f. Okay. This minus represent that the image formed in diverging lens is virtual image, and this minus indicates that the diverging lens has negative focal length. And you see in figure di, this distance is di, f focal length, and dO is distance between object and lens. Now I will tell you one point. This point is very important. Okay, how to know which side of the lens is back side of the lens, or which side of the lens is front side of the lens. Incident ray, you see incident ray. Incident ray is comes, okay, and pass through a lens. This incident ray, we can say incident ray means the front side of the lens. Here you know that the light passing through the lens, and is refracted. Refracted light, it means back side of the lens. Here is inside of front side of the lens, and it is this side, we can say back side of the lens. Let me tell you sign convention for 10 lenses. dO is positive if the object is located in front of the lens. It means here real object. Real object. Positive sign represent real. If dO is positive, it means real object. DO is, sorry, it is negative. DO is negative, it means represent virtual object. When we have virtual object, when we have that for combination lenses we have virtual object. DI is positive. Image far in back of the lens is real. If the image far back of the lens, it means object is real. Or I will tell you, a positive represent real. If DI is positive, it means real image we have. DI is negative, it means image far in front of the lens. Minus negative represents virtual image. If DI is negative, it means represent image, virtual image. And if focal length be positive, it means represent that the lens is converging lens. If the F is negative, negative indicates or represents the diverging lens. You see, and I will tell you this. DO is in front of the lens is positive. DI is negative. Why? Because DI is the image form in front of. The image form in front of the lens. If the image form in front of the lens, the image is virtual. That is why I wrote here minus. Because the image form in front of the lens, it is virtual. And also you know that diverging lens has negative focal length. And also in this equation, all sign is positive. You see? Object is in front of the lens, is real, is positive. Image is far, you see. Image far in back of the lens. Image far in back of the lens is positive. And also you know that diverging lens has positive focal length. This is the sign convention for 10 lens. Let's solve more question about equation, 10 lens equation. Example number 1. Find the location of the image of an object which is placed 45 centimeter in front of a converging lens with a focal length of 30 centimeter. I will solve this question. DI is okay. Find DI. Find the location of image. Find DI. DO is distance of object is 45 centimeter. F is 30 centimeter. Find DI. Okay, converging lens. For converging lens, we have this formula: 1 over DO plus 1 over DI is equal 1 over F. 1 over DO, 45 plus 1 over DI, we don't know, we should find. 1 over F, what is F? 30. Now, I bring 1 over 45, bring another side of the equation. 1 over DI is equal 1 over 30 minus 1 over 45. 1 over DI, 1 over DI. What is the LCM of these two numbers? 30 and 45. We take 90. Okay, 90 divided by 30 is 3. 3 times 1 is 3 minus 90 divided by 45 is 2. 2 times 1 is 2. Okay. Now 1 over di is equal 3 minus 2 is 1 over 90. If we multiply this, di times 1 is di, 90 times 1 is 90 centimeter. You see, the sign of di is positive, means that the image form real. The image form in converging lens is real because the sign of di is positive. And we found the location of image 90 centimeter. I solved one more question about 10 lens equation. Conclude the distance of image of an object which is placed 30 centimeter in front of diverging lens with a focal length of 50 centimeter. Find di. Do is what? 30 centimeter. F is what? 15 centimeter. And okay, for diverging lens we have this equation 1 over do minus 1 over di is equal minus 1 over f. 1 over do 30 minus 1 over di. What is f? 1 over 15. Okay, I bring 1 over 30 on the other side of equation. Minus 1 over di minus 1 equal to minus 1 over 15 minus 1 over 30. Minus 1 over di is equal, what is the LCM of these two numbers? 30. 30 divided by 15, 2. 2 times 1 is 2, minus 2. 30 divided by 31, 1 times 1 is 1. 1 over minus 1 over di is equal. Minus 2 minus 1 is minus 3. Minus 3 over 30. Well, finish minus my minus, okay? And 1, 3, 1, 3. If we multiply this one, di times 1 is di. 10 times 1 is 10 centimeter. Okay, the distance of image, distance of virtual image. Okay, the image form in diverging lens is virtual. The distance of virtual image is 10 centimeter. 10 centimeter, and these are all about today's lessons. If you have any question about today's lesson, try to comment below, and also don't forget follow our YouTube channel. Catch you later. Have a nice day.